I'll just continue up here. This is equal to 3. Okay, what does the blue part there, what does this blue part all turn into? Parenthesis, x, what? This number right here. This number, is it positive or negative? This is a positive number. So I'm going to put here plus 2/3, right, squared. Had this been a minus 2/3, I'd put minus 2/3. That's this blue part. That's this, these 3 terms. If you don't believe that, if you don't believe that that's true, I would challenge you to take that on the side and FOIL it out, and I promise you, you will get back these 3. What do we still have, though? This, right? We have that still there. So let me write that down. We have minus 4/9, minus 1/3, and then close the parenthesis that is here with the 3. Can you put these 2 together? Yes, you need a common denominator. Yes? You have a question? No? Okay. Right? You can put these together. You need a common denominator. Let me do that over here real quick. You're doing minus 4/9, minus 1/3. So I can rewrite that as 3/9, common denominator. That's minus what? Minus 7/9. Okay, so my next line looks like this. 3, parenthesis, x plus 2/3 squared minus 7/9. We're almost there. One more step. What's that last step? Distribute the 3 through. Distribute this 3 through. So when the 3 comes to here, again, I cannot push the 3 inside this parenthesis because of the squared, right? Order of operations. So I just have the 3 sitting in front of this. And then over here, I do pass the 3 here. And can I do anything with that? You would get like 21/9, but I think that reduces out, doesn't it? No. Yes? What would it be? Negative 7/3. Negative 7/3. There it is. There it is. All right, let me ask you some questions. Does this parabola open up or down? Up, because 3 is positive, right? Okay, what is the vertex? What is the vertex of this parabola? The opposite of that number, negative 2/3, and then negative 7/3. The biggest thing here is the completing of the square technique. The taking half of that number, right? Dividing it by 2, squaring it, adding it and subtracting it, that hidden 0, right? Keeping track of everything. All right. Good?
So is this a foolproof way of finding the vertex?
I'm sorry?
Is this a foolproof way of finding the vertex?
This is a, yeah, I mean, if you do that all right, if you do all of that correctly, then you should be able to identify the vertex. Absolutely. Okay, so I'm ready to move on to the next topic, all right? But y'all wanted to see a function with some nasty stuff in it, right? So let me do quickly a problem similar to like what I sent you with homework, and let's just work through it. I think it's really like, well, let's just make it bad. How about we just make this as bad as I can imagine it being, right? So how about negative 2, let's go with x squared. Let's go with plus 7x plus 1. There we go. That should be pretty bad. All right, I want us to sketch this. So the first thing I'm going to do is determine if it opens up or down, which it opens which way? Down, okay. I've given it to you in standard form, okay? I would not recommend right now to convert it to vertex form, all right? I would not do that if I were you. I would just do the steps we did last time, all right? So it opens down because A is what, -2? And that's negative. Negative parabolas open down. Or if you have a negative A, it opens down. Second step is vertex, right? And to find the vertex, we use a formula. H is negative B divided by 2 times a. What is negative b for us? Negative 7 over 2 times negative 2. That's negative 7 over negative 4. 2 negatives become positive, 7 over 4, right? And that is a decimal, right? 1.75. 1.7. So maybe this decimal's not as ugly as the ones you got, but if your decimal kept going, let's just round it one or two decimal places. That's it, all right? You what?
I was supposed to round.
Well, I mean, how far do you go, right? You don't go like 13 decimal places, right? At some point, you need to stop somewhere. So, just 1 or 2 decimal places will be fine here, right? We're not trying to land a man on the moon. We're just trying to get the vertex, right? All right, k. How do we get k? We take that answer and we plug it into our function. So negative 2 times 1.75 squared plus 7 times 1.75, then plus 1. And this is where I just get my calculator out, right, to make my life a little make my life a little easier, work a little faster here. All right. So all I'm going to do is just type it all in and give you a final answer. I get 7.125. And okay, you know what? I'll put 3 decimals there, whatever. I'm not real big on rounding in this class, all right? We're not trying to be super precise here. Remember, aren't you going to draw these for me? Are you going to be able to draw them accurate to like the thousandths? No, you're not. So, I mean, you know, I don't need you to try and give me like this out a bunch of decimals. So there's my vertex, right? Questions? Third, quick sketch. My vertex is, let's see, the h is to the right, 1.75. My k is up 7. So I'm up here somewhere. And it opens down. So yes, I do have 2 x-intercepts, right? I have 2 x-intercepts. So I've got to go find them now.
It'd be easier to find the y-intercept first.
Well, yeah, I think it would be much easier to find the y-intercept first. But I'm just following the procedure. The procedure, we're going to do x-intercepts, then y-intercepts. So 4th step, x-intercept, intercepts. And to do this, I'm going to use a quadratic formula, right? Right, because this isn't going to factor. There's no way that's factoring. So I'm going to set negative 2x squared plus 7x plus 1, set it equal to 0, right? That's what x-intercepts are. It's where the function is equal to 0. And then I use a quadratic formula. My quadratic formula here would be negative b, that's negative 7, plus or minus the square root of that number squared, so that's 49, minus 4 times a, which is negative 2, times c, which is 1, all over 2 times negative 2, right? And again, I have to crank this into my calculator. The biggest place that students make mistakes at this point is right here. They messed this up. That part, they messed that up. The 49 is the 49. The 49 is never going to change. The question is, what's after the 49? It's either going to be plus a number or minus a number, and you have to figure out if it's plus or minus. So the way I think about it is I just say, all right, I'm going to just take these numbers and multiply them together. What's negative 4 times negative 2 times 1? So what's a negative times a negative? Positive times a positive? Positive. So I know I'm going to add this number. Negative 7 plus or minus square root, 49, what? I said I was going to add? Add what? 4 times 2 times 1? 8. Okay, all over negative 4. And then that is negative 7 plus or minus the square root of 49 plus 8, 57, all over negative 4. And then I get on my calculator, I do the square root of 57, get a decimal, 7.55. 7.55. all over negative 4. You okay with this? And now you have two different scenarios, right? You do negative 7 plus this number, right? Negative 7 plus this number, and then divide that by negative 4, and then you do negative 7 minus this number and divide by negative 4. So I'll just give you those two answers. I'm doing negative 7, I'm adding 7.55, hitting equals, then dividing that by negative 4. I get negative 0.137, I'm going to go negative 0.14, close enough. That's one answer. The other one, I take negative 7, I subtract 7.55 and hit enter, and then divide that by negative 4. I get 3.64. Those are my two x-intercepts. And then finally, the y-intercept in a graph. So for the fifth step, y-intercept 1, right? Because it's in standard form, this c is always the y-intercept. And now I put together my picture. I think I can probably squeeze it in right here. So on my picture, I start with the vertex, which was, this was my h, that was my k. So, and my x-intercepts only go out to what, like 3.6, negative 1.4. So my x, I only really need to go between like here and like, I don't know, like between like negative 1, let's say this 1, 2, 3, let's say that's 4 out here. That should be able to fit all my x stuff, right? And how big is my y stuff? So my vertex, this is the k, right? That's 7. So I need to be able to go up 7. And it's going to open down. So I'm just going to say this is 5, and this is 10. All right, here we go. Vertex. Go to the right, 1.75. I go up 7.125, about right there. How do I know that that's 7.125? How do I know that? Well, because you're going to write next to that point 1.75, comma, 7.125. And that way I know that you have the right point, right? That's your vertex. Your x-intercept, negative 0.14. That's like really, really close to the origin there. It's negative 0.14. And then the other one is 3.64, is somewhere around here. 3.64. Y-intercept, we have one more thing. The y-intercept is 1. It would be about right there, right, at 1. And then draw your parabola, right? So through here, and then through there. Okay. So we are officially done with this section. I'm going to just show you the homework for this. These are the homework problems. Right there, 31, 33, 35, 37. I want you to completely ignore the instructions, all right, on those problems. Ignore the instructions. What I want you to do is for each of those functions, just sketch them, all right? Sketch the functions. Each one of those is a little bit different though. Like look at number 33. Can you all see number 33? How would you do that? What form is that given to you in? Number 33. 33 is given to you in vertex form, right? So you already know the vertex. So follow the procedure, steps 1 through 6, right? But you already know the vertex. Number 37, on the other hand, is in standard form. So, you know, you're going to use the same procedure, but you're going to have to go find the vertex using the formula. 41 should be interesting because there's a fraction, so it'll be interesting to see how you do that. All right, and then the next problems are right here. These 3, again, those are all in standard form, right? All right, we're moving to the next section.
Do you have any completing squares? Is that issue?
None of these problems ask you, well, my instructions are for you to just sketch these, right? Just sketch them. So I showed you the completing the square because I want you to have walked out of this class at some point and you saw completing the square, right? You saw it. I showed it to you. We will possibly use the completing the square later, but it was more just for the technique of it. I wanted to show you how to get from one form to the other. But if I do see any of you in Cal 2 down the road, if I do, remember your face, and I'll be like, hey, I know we did this. I know we did this. All right. Next topic. Good news is that it's not a huge, we're not stepping away from quadratics yet, all right? That's the good news. Bad news is students seem to always forget this, all right? So quadratic inequalities. Quadratic inequalities. So let's just do a real quick reminder of what an inequality is. So recall that if I say x plus 1 is greater than 4, and I ask you to solve this inequality, you would look at it, the reason you know it's an inequality is because that's not an equal sign, right? It's this little, like, remember that little alligator thing you learned when did they teach you the alligator? Yeah? So this is an inequality. You're trying to find any x values that satisfy this. So like, for example, if I plug in 0, does it work?
No.
0, plug in, no, it doesn't work. What's a number that I could plug in that would work?
Anything greater than 4.
Give me an example.
4.
4 plus 1, that would work, right? 5 plus 1, 6 plus 1. There's an infinite number of answers, right? So to solve this, all we would have to do is subtract 1, and you get x greater than 3, right? X greater than 3. Just subtracting 1 here, subtracting 1 there. And so visually on a number line, what this means is that if this is 3, we don't include 3, but anything to the right of 3 should work, right? If you plug in, see 3 won't work, right? If I plug in 3, go back to this original. What happens if you plug in 3? You get 4 greater than 4. Is 4 greater than 4? No, right? So it has to be a number bigger than 3 and then anything. That all makes sense, yeah? Okay, so what about this? Can we solve that the same way? Can we subtract 1 on both sides? Yes, okay. Yes, you can. I'm going to confirm, yes, you can. All right, so that's this, right? Now what? You want to divide by -1, right? To get rid of it. That's what you would do. Like if this was negative x equals 3, right? We would just divide both sides by -1 or multiply both sides by -1, and you turn this into x equals -3, right? Everyone, this is all good. Everyone's happy here, right? But I saw you raise your hand in the corner. What's wrong? You have to flip the sign. You cannot, if you divide both sides by a negative here, you have to flip the sign. Why? Do you all remember that rule? There's a rule that if you have an inequality and you divide or multiply by a negative number, you must flip the sign over. Let's see why. Can I show you why? Okay, let's do it wrong first. Okay, let's do it wrong first. Let's take negative x greater than 3. Let's divide by -1. Let's divide by -1. This will become x. Let's not flip the sign, and then this becomes -3. Right? Let's see why that doesn't work. What does this mean? This means on a number line, here's -3, and we are supposed to be, our x's are supposed to be greater than that, right? That means -3, you can't be -3, but you can be anything to the right of -3. Somebody give me something over here. 4. 4 is to the right of -3, isn't it? 4 is over here? Okay, let's check 4 in the original problem. Here is the original problem. Let's check 4 in here. If we try and plug in 4, we get -4 plus 1 is greater than 4. The left side is -3, and -3 is definitely not greater than 4. Right? It doesn't work. It doesn't work. The reason it doesn't work, okay? This just shows you it doesn't work, right? But the reason it doesn't work is because what happens if you take a number and multiply it by a negative? Your answer, like take a positive number and multiply by a negative, what happens? It becomes negative. If you take a negative number and multiply by a negative, it becomes positive. That weird kind of behavior of how your signs change, that's what's happening here. When we divide by negative, we have to take into account the fact that that could change the signs of things. It could be positive or negative. So to resolve that, what we do instead is we just say flip the inequality and it will fix all of that for us, all right? So on this step, right here, I'm going to come back and do it the right way. I take this, divide by -1, divide by -1, and then I need to remember I'm going to flip this. You only flip it when you divide or multiply by a negative, right? If I divided by 2, then I wouldn't flip. I wouldn't flip. So let's do this now. The left side becomes x. I flip the inequality, and now it becomes -3. And now my answer looks like this. It's all the values of x smaller than that, which is to the left of this. And then you can check for yourself. We plug in anything over there, it'll work. What's the number over here? -4? -4 over there? Try that over here. Plug it in right here. See, you have a negative right now, but you're plugging in -4. And then +1. Is that greater than 4? Yes, right? The double negative here. See, the double negative gives you a 4, and then you add 1, you get 5. 5 is greater than 4. See? So just remember, this is for inequalities, right? You always have to be careful with that dividing by a negative. Okay, our goal is not to do what we just did. All right, these inequalities are not what we call quadratic inequalities. These inequalities are called linear inequalities because if you look at this, if you were to make it an equal, this is what we would call linear equation because x is raised to the first power. These are linear inequalities. And I'm assuming you have some experience solving those. What we want to study are quadratic inequalities, which are a lot more complicated than linear inequalities. So let's start out with our first example of a quadratic inequality. I want us to solve this. So let me first point out that if this was an equal sign, right? If this was an equal sign, this is just a quadratic equation. And we could either try and factor it or use a quadratic formula. Do you all agree? If it was an equals, but it's not an equals, right? So how do you do it? Should I show you the wrong way or not? I hate showing the wrong way. I see some people saying no, some people saying yes. Y'all don't want to see it? Yes, you.
I'll remember the wrong way.
Hmm?
And then I'll remember.
Okay, so I'm not going to show you the wrong way. I'll just verbally tell you what people do. What they do is they just like factor this, and they factor and they get 2 answers, and they just make both answers greater than 0, and that's wrong. Okay, you can't do that. So for quadratic inequalities, there is a set of steps. All right, and I'm going to show you the steps. First step for a quadratic inequality, turn it into an equation. So I'm telling you, yes, for right now, I want you to act like that's not an inequality. And then what we're going to do is solve it. Okay, just like I had walked in here and said, all right, everyone, let's solve this quadratic equation. Your first step of a quadratic inequality is to turn it into an equation. And now solve. So do we all see that this factors? If you didn't see that factored, you would have to use a quadratic formula, right? Which would take you a lot longer. But everyone here should be able to get to this step where we get the same answers. Set each factor equal to 0. Our 2 solutions are 5 and -1. With me? That's the first step. The next step is going to seem extremely weird, all right? The next step, draw a number line. and plot your answers. Okay, so I'm going to come over here now, and I'm going to draw a number line, and I'm going to put these two answers on them. -1 and 5. Now, what I'm about to do is I'm going to figure out whether or not, I guess I'm going to try and figure out what regions of the number line satisfy this inequality. I know what happens here and here. What happens at -1 and 5? What happens to this left side? At -1, if I plug in, I get what? If I plug -1 into this, what should I get? No. Where did this come from? That was me setting it equal to 0, right? I got these two answers. So I know that if I plug -1 into this, what do I get? 0, right? And 0 is not bigger than 0. So I know that that's not an answer, right? If I plug 5 into this, I get 0, and it's not an answer, correct? But we can imagine that this breaks up our number line into 3 separate regions. I have the region, everything to the left of -1, everything between -1 and 5, and everything from 5 on. And what I need to figure out is whether or not numbers here work, or here. I'm going to test some values of x. If a number right here goes in here and works, then everything in this region will work. If a number in here works in here, then everything in between here and here will work. And finally, if a number over here works in here, then every number over here works. So you have to test points, right? That would be the next step. Draw a number line, plot answers. Here we go. Pick test points in each region, right? And then test into the inequality. In other words, we're going to take some test points. Somebody give me a test point over here, something I can plug in that's to the left of -1. -2. Okay, I'm going to circle it. I'm going to test that point. Something between -1 and 5. Anything you want. 3. Okay, 0 is a good one though, right? Okay, but I'll use 3. And then something over here. 7. Okay, there we go. Now, everyone might have different test points. Okay, everyone might have different test points. But the procedure is that if anything over here works, everything over here works, right? So let's test each one of these. Let me test -2. Testing -2. I'm testing it into this, right? -2 squared minus 4 times -2 minus 5. Is that greater than 0? Question. It is. It is. Because this is 4. This is plus 8 because 2 negatives multiply to be positive. Minus 5. Is that greater than 0? Absolutely. That works. And that means everything over here works, right? Everything over there works. So if I go and I start to think about shading this number line, we know everything over here works, right? Now, what about -1? Does -1 work? -1 did not, right? Because that didn't -1 make it equal 0, and we want it to be strictly greater than 0. So -1 would not work. All right, now we need to check between here and here. So does 3 work? Testing 3. Test x equals 3. So we get 3 squared minus 4 times 3 minus 5. Is that greater than 0? Question. 9, take away 12 minus 5, greater than 0. What is that, -8? Yeah, that's -8, right? Is that greater than 0? No, -8's not greater than 0. Which means nothing in here works. And then you have to test 7. Okay, you have to test 7 as well. And now, just to save time, I'm going to tell you 7 does work. All right? You don't use 5, because we know 5 gives you 0, right? And so we know it's everything this way. I have not put my answer yet. This is just a visual representation of my answer. the final answer to this inequality, right? The solution set for this inequality is negative infinity to negative 1 union 5 to infinity. It's any x value to the left of negative 1 and any x value to the right of 5. What do you think? All right. Yep, this is it. Well, okay, so let me say this. There is an actual really fast way to do it. But the problem with this method is that it's not going to help you when we get to the next section, because it only works for quadratics. It doesn't work for general polynomials, which is where we're headed. But I'll show you what the super quick way is, and that is, you know, right? You know that if you were to forget that, if you graph this, what would it be? What is that? That's quadratic, right? Does it open up or down? It opens up, right? If I asked you to find the x-intercepts, you would do the step that we did before, right? You would get the 2 x-intercepts. So if I were to ask you to graph that, your graph would look like this. Here's what you know. You know that you have x-intercepts at negative 1 and 5, right? And you know the parabola opens up, right? So it has to go like this. Now, you don't know what the vertex is right now, but that's kind of like what it would look like, yes? And this is saying, where is that bigger than 0? So what it's saying is, where is your graph above the x-axis? And do you see that to the left of 1, you're above the x-axis, and to the right of 1, you're above the to the right of 5, you're above the x-axis?
So just ignore everything below negative 1 and 5.
Yeah, because this is where your function is below, right? Less than 0. We wanted to know where it was greater than 0. But like I said, that way is great for quadratics. But once this function becomes more complicated, then we can't do this. All right? Also, you might think this, like, if this one works, this one didn't, this one does, right? So why not just find the first one, right? Like if you say, if this one works, then you know it's works, doesn't work, works, right? Or if this one doesn't work, you would say works, doesn't work, yeah? That works for quadratics, but again, in the next section, it might be that it works, it doesn't work. Or it might be, it doesn't work, doesn't work, doesn't work. Like you have to check each one. So I'm trying to give you more of a method that's gonna be consistent and work the rest of the way through. All right, how are we doing on time? All right, we should do another one. I'll leave that up there. So I want us to try and solve this